they're basically moral tales that is very discovery. And there are collection stories that my grandfather used to read to me. They're extremely gruesome. The title character is his name is to Sean was the story
Okay. Ladies and gentlemen, everyone, welcome back. I know you missed it. Welcome back to campus. Welcome back to EECS 404, Game Engine Architecture. Now, you've had a nice long break, and I know you all told me that you were going to work a little bit over break, though I didn't really want you to. So, I'm glad that you are all caught up now. All right, you're all caught up. You are halfway done with homework 7, right? Right? Yeah, right? Okay, right, great, wonderful. So it's not really a problem then. Well, in case you haven't finished homework 7 yet, you should know that you still have 1 week remaining of homework 7. And that means you've got 1 week left to get familiar with Lua, this beloved minimalistic language we've been talking about lately. And you've got a week left to get that all integrated into your engine, to bring those life cycle functions to life, bring all those nice libraries to life, input.getKey, all that good stuff, all right? I think once you get into the meat of it, you'll find that this homework goes pretty quickly, but it's those first few test suites that are really a killer. So if you can knock those out, that's really, really going to be helpful to you. And if you get confused on those first few test cases, having office hours available where we can draw things and explain things to you is going to be a big, big win. Don't let homework 7 get into this weekend, okay? Because the number of office hours remaining is going to dwindle, and if I'm too busy on Sunday, we might only get a few minutes to talk, all right? That's it. So do your best. Try and see if you can catch up on homework 7, all right? I know if you are feeling like you're behind, I've got news for you. About 70% of the class is behind, all right? So don't feel too bad. But then again, if you are on track, if you're halfway through homework 7, that means you are in good position indeed, all right? Okay, if you look at where we are in the middle of homework 7. We're closing in on it. Next week, we're going to have your 4th quiz, and it's going to be all about homework 7. It's going to be all about Lua. It's going to be about integrating Lua into your engine. And so catching up on homework 7 will help you on this 4th quiz as well. We will then move into a series of 1-week assignments. Your homework 8 is going to be a fairly natural, not too difficult extension of homework 7. And then homework 9 will be another extension on top of that. Again, not too difficult. The students last semester, those who completed homework 9, they said it was the easiest one. Okay? A victory lap, they said, actually. So hopefully you will have a similar experience. I might make homework 9 a little bit more difficult, but that won't mean much. It really is an easy assignment. I think you'll enjoy it. Okay? So, today, we have a couple things I want to talk to you about. One is a big one, Roblox. Okay, Roblox hires a lot of my students. I think they are number 1 in terms of my former students working there right now, actually. And they are quite an interesting game engine. They are one of those engines that came out to a big thud, okay? It was a disastrous launch for the Roblox team. They really didn't have pretty much any customers or users for quite some time. The initial release was in 2006. It was called Dynablocks. It took off around 2015 or so, but by took off, I mean it really started to gain some momentum. It had been building for some time. The team was able to sustain themselves long enough to finally figure out their audience and to start to gain some traction. You can read the Wikipedia article here. The current market cap, $44 billion. That's not too bad, is it? Roblox is definitely that example of investors preferring a platform over a product, okay? Has anyone been playing the recent Resident Evil game? Resident Evil Requiem, Resident Evil 9, it comes out, it's amazing, fantastic, great review scores. It's a long game. It is really well received. It sells something like 5 million copies in about 5 days. Not too bad for any team that isn't Rockstar, okay? The problem, though, is that Capcom only has products. They do not have platforms, okay? So what is the market cap? Capcom. What's their market cap? Only about $2 trillion. Wait, that can't be. Oh, 2 trillion Japanese yen. Okay, hold on a second. 1.8 trillion. No, okay, hold on a second. Okay, what is this? $11 billion, is that right? Yeah, $11 billion. Roblox is about 4 times as valuable as Capcom. Okay, forget about Street Fighter. It doesn't matter. Forget about Resident Evil. It doesn't matter. Okay, one of the reasons that a lot of Western companies in particular are this way is that they never want to have a one-off great product because that's just a one-time bundle of money, okay? That doesn't get you the kind of growth that a lot of Western investors are expecting, and so platforms are the key, not products, but platforms. And, you know, I don't have to be happy about it. This is simply the way it is. You don't have to be happy about it. So what is Roblox? If it's not a game, it kind of looks like a game, but if it's not one, then what is it? Well, you know what? I don't want to describe it to you. I want to play it, okay? So let's see if we can play some Roblox, all right? We're going to go Roblox. I'm going to log into Roblox. And we're going to see, I recently saw a game that looked pretty promising. In fact, can I just open it up like this? Roblox player. One thing you might have seen right there is that there's a Roblox player and there's a Roblox studio. We opened up the player, i.e. we're looking to play some games. I saw this game on the front page, Scary Shawarma Kiosk, The Anomaly. Okay? And so I have no idea about this game. I know nothing about it. I didn't even play it. Okay? And this is my first experience. You know what this reminds me of? Gary's Mod. Okay? A horrible first experience whenever you start playing the game. It just kind of throws some text up at you. And it's like, read this. By the way, seizure warning. And I've got this big thing in my face. I've got this leaderboard. It looks like there are people running around. I'm not even going to read this. It's not like it's telling me anything. I've got a reward. We're playing a mobile game, okay? I'm going to claim that. Claim. I don't even know what I claimed. But there are a lot of people here. So can I talk to them? Can I hit like T to chat or something? Anyone? What? Slash. I don't see it. It's not working. What is it? Are you sure? Maybe it's disabled. We can't talk. Because
they did some like ID verification recently.
Oh, maybe it's safety, huh? Players. Short shift. Fewer customers, events, and anomalies. Each shift is randomized. Am I playing? I think this is like a lobby. They're trying to put more players in here. Except I'm the only player. So, okay. Biggest update yet. I feel like I'm getting an ad during the loading screen. Okay. There's this feeling of unpolished that you should be getting here. Like it's the Wild West, right? It's dirty, it's grimy, okay? We're in the trenches here. Who knows what could happen to us? I'm getting serious itch.io vibes from all of this, okay? It's like if itch.io, where every game was multiplayer. Okay, we got a scene transition. That's cool. You don't often see that. The whole game is dark, though, so you can barely tell. Shawarma, okay? And my income is 4,000. I got icons everywhere. Am I going to walk in here? There's trash. Oh, E to open. Look at that animation. Look at that. Okay. Let's see here.
Welcome to your night shift at Shawarma Kiosk. Let's start with the basics. Step 1, turn on the grill. Customers just love their shawarma hot.
Is this the grill? Turn on the grill. Is that it? Oh, it's FNAF. Okay. Oh, there it is. Yeah.
Now,
Oh, it's spinning. That's awesome.
everyone know you're ready.
Open the window. Here we go.
Before serving, be sure to read the safety rules. They're super friendly, just like you know.
That's what I look like, huh? Okay. I don't know. Okay, so I'm a shawarma like kiosk person, okay? Like I've always dreamed of being. And I'm not exactly sure what this game is about. I think it's multiplayer because we had a bunch of other people going in as teams. But yeah. Is anyone gonna come? Hello? Well, I gotta read the rules, huh? How do I read the rules? Oh.
And while you wait, feel free to watch
Okay,
TV.
if a smiling customer comes in, hand him a soda. The wet, moving bundle he gives you must stay sealed under the counter. Every Friday at 2 a.m., a car with no driver will arrive. That's an inspector. Exit the back door. Never look at the shawarma stand during the inspection. Should the meat on the skewer begin to pulse and moan, turn off the grill and leave. Do not listen to the voices in the meat. If a faceless man comes to order, serve him, but never look at his face. Some customers must not be served at all. Close the window immediately. In a case of unusual anomalies, act accordingly. I'm not sure what that even means. Okay, I can't get this off of my face. Oh my goodness. Is he smiling?
To shawarma.
To shawarma, okay.
What? You're judging me for something. Everyone else eats trash. I know what's good. Got it. 300 to go.
Okay, he gave me money. Now I gotta start with lavash. Oh. Oh? Huh? Oh, I dropped it. Damn. How do I pick it back up? Oh, okay. Add sauce. Okay, add cheese. Isn't this what you pay tuition for? To watch this? Watch us explore Roblox? Okay. Roll it. All right, not too bad, huh? What? Oh, I got to do another one? I'm not going to do that. I want to show you one more game, okay? So we're going to leave this game. So let me see if I can find something a little bit more interesting. Shrek in the Back Rooms. How about that? Okay. We'll see if anyone's playing Shrek in the Back Rooms. So this is a game that is multiplayer by default. And look at that. We even have some people here. Okay. So it's multiplayer by default. Oh my God. Obnoxious, man. Okay, team up. Can you come in here? Oh, we got a teammate. No way. Listen to the sound effect. No, stay in here. Okay. Oh. Did we get... What? What is happening? Get carried? I'm carrying this man. How do I play the game? How do we play? How do I talk to the person? Get voice chat. No! I gotta check my age. Does anyone know how I start the game?
I think you need to walk back out one day.
Really? You just kind of go in and...
I don't know.
All right, I'm just going through. Let's go. Use arrows to find the exit. Oh my god. I can buy this with Robux. I don't have enough money. Oh my god, it's Donkey. He's after me. Oh no. Oh, he's too fast. Oh no. Oh, disaster. And then Venom is just standing here. Okay, so this is basically Gary's mod. It's Gary's mod for kids, which you always would have suspected would have kind of worked, right? Gary's mod is a place where anything can happen. You have servers that have been made by other people. Servers programmed in Lua, by the way. Lua is the scripting language of Gary's mod. It's also the scripting language of Roblox. Roblox comes with a tooling system called, let me see if I can get out of here. The last time I tried to escape Roblox, it did not want me leaving, actually. So how do I need to kill this in the, okay, there we go. If I go over here, I can go Roblox Studio, and Roblox Studio pops up. This is actually a program you can use to edit your game. It's an integrated editor, and I think I'll show you that a little bit more maybe next time. But Roblox is a game engine that is multiplayer first. So the reason all of these games, they look crappy, they seem very unpolished, but they do have these online features working by default. They've got these microtransaction systems, mobile-style game systems working by default, is because Roblox gives you these out of the box. And that's a large part of the appeal. You can start making a game for you and your friends, and you don't need to take the MMO architecture course to learn online programming and network socket programming and stuff like that. It runs on most platforms. It has a desktop client, which you just saw. It has a browser client, a mobile client, a console client. So it's very easy to play and get into and start playing. It has a very young audience, which is kind of interesting in that it makes it extremely vulnerable to controversy, and they have to be extremely careful with how they handle their players and content moderation because of the super young audience. And so you can kind of sort of see this in here. There is a 20-minute long Roblox controversies iceberg video with 2.2 million views. And so Roblox has really messed up a lot of things, especially, unfortunately, relating to their young user base. Developers on Roblox make a ton of money, actually. Roblox has more concurrent users these days than the obscure indie title Steam has. And that is Steam, all of Steam, okay? Not just one Steam game or Valve's games. Roblox is bigger than Steam is these days. It's kind of hard to believe, isn't it? A lot of developers don't want to use Roblox or engage with it because of its young audience, because of the problems that Roblox and their team, the distaste of it all, and the fact that a lot of games in Roblox look like this, all right? They look very lo-fi. They're not very prestigious. It's not a prestigious place to make your next game. But it is where the market is. A lot of people who will pay a lot of money, and you have very little competition on Roblox, okay? On Steam, all the professional devs are there. On itch.io, all the hobbyist devs are there. On Roblox, there aren't many devs, but there are a ton of users. So anyway, this is a little screenshot of kind of what the Roblox Studio editor looks like. Big surprise, you have a big viewport in the middle. On the right side, you have a bunch of objects you can mess with. And on the left side, I think you can see where some of your objects end up going. You can click on an object, you can start adding scripts to them, just like you'd expect, and those scripts are written in Lua. So a very, very familiar situation if you decide you want to hop into Roblox. One interesting thing is that Roblox has a monetization system. You might have seen this in some of the gas stations or shops you've walked through, these Roblox cards. This is Robux, and Robux is an in-game virtual currency that users can spend on things in the game that you make. Now, what's crazy about this, do you know what the standard cut that like Apple takes for every transaction in your app on the App Store? You know how much money Valve will take from your cut on Steam? Nintendo takes, right? Sony, Microsoft takes how much?
That's a 30%.
30%. That's right, 30%. Roblox takes 70%. Okay? That's another reason maybe a lot of developers just find Roblox a bit distasteful and they don't really want to work there. But they don't want to make their game on Roblox. The thing is, though, there's so many users. You can actually, did you know that Ann Arbor has multiple Roblox-focused game studios? Evan Stoker, who teaches EECS 298 with me, the 3D art, tech art, and animation course, he knows Blender and he knows game dev because he runs his own Roblox studio. And he makes a big bundle of money. And usually when I see him, I'm like, Evan, why are you even getting a degree, dude? You made it. Like, what's the point? Why are you going through undergrad? Okay? And it doesn't even matter anymore. But there are a lot of small studios making money hand over fist in Roblox. It's so much the case that Corbin Reeves and I are trying to create a Roblox development course so that some of you can get in on that before it gets swamped with developers like the rest of game dev has become. Okay, I want to show you this trailer, and then we'll talk a little bit more about the development experience. This will give you a good feel for what Roblox is. If you don't really know what's going on with this thing. Okay, let's take a look. Take a note of the diverse art styles you see, because it's not just this basic kind of Lego style art style that they're going for. Let's take a look. So you can tell that Roblox is kind of trying to shed its just for kids image, right? You see a lot of games with higher fidelity in there. I'm sure Roblox would be very excited, for the next big game in maybe like Call of Duty series or something, or some big AAA team to give Roblox a shot and try and make their next product there. I'm sure they would be thrilled. I'm also sure it's not going to happen. Okay, so this is a multiplayer by default engine. You just get synchronization of objects and characters. You get multiplayer lobbies and team formation. You get all this stuff right out of the box. The scripting language in here is Lua. It has a component-based situation very similar to that of Godot. But instead of calling their actors a node or a game object, they call it a part, okay? So you create a part to act as an actor, then you create more parts underneath that part, each with a script in order to represent components for that actor. Parent the components to the actor, and boom, you have a Godot-style situation. And the Godot situation is very similar to the Unity situation. So, and it has an all-in-one integrated editor. It has scripting, auto-completion, code completion, everything you would kind of hope for. So it is a very, very powerful engine. Maybe in the future, we will spend a bit of time kind of using it to make a sample game. Might be informative for us to do that. But we will not do that today, okay? So that's Roblox. It is a very big, powerful company. It is maybe the dark horse engine behind Unity and Unreal, okay? People don't really think of Roblox as an engine, but you certainly could think of it as an engine if you wanted to. Okay, how is Homework 7 going for people? I know some of you have completed it. A lot of you are in the middle of it. Some of you haven't reached it quite yet. That's okay, but just be careful. It's very easy to accidentally get a week behind and then, oops, not one assignment is 20% off, but every assignment is 20% off, which means your final grade is going to be 20% off. That stinks. Okay? How are things going so far? Good? No comments. William, how's it going?
Good.
Good? Very good. All right. Well, you're not the most talkative group, okay? That's okay. You do not have to talk. I don't have a participation grade in this course, all right? So don't worry about that too much. All right, I already showed you the website that the A2 game engine has. You can download the engine, the compiled version yourself. Unfortunately, I only have Windows builds right now. Something I recently added, I think I told you about this, didn't I? But I added a few sample games into the website. You can download these games. You can play them if you want to. And you can look at all of their Lua code. You can look at the entire source code for the game. You can't find the source code for the compiled engine. But one of the best ways to understand what is happening on Homework 7 is to actually build a game with your engine. You can do that as you finish up Homework 7. If you haven't finished Homework 7 yet, you can take a look at an engine that has been finished, and you can look at how a game is structured. How is that game put together? How does it actually do its job and work? How are mechanics made? And that's actually what we're going to do today. We are going to build a game in our engine together today. It's going to be a very simple game. But it's going to hopefully give us a stronger feel for what our game's architecture actually is, what our engine's architecture is, and how a game is built using those tools that we're creating this week, okay? So if you're ever really confused, you can download some of these games, poke and prod at them if you want to. That might give you a good feel for how things should work and what your engine needs to do to support such a game, okay? You can also take those games and you can put it in front of your engine and see how well your engine makes them run. If any of my games make your engine crash, then it's a good hint that you might need to work backwards and resolve that crash, okay? Okay, last time we didn't quite finish this lecture right here. We talked about component architecture. Do you remember that? And we talked more about how you can kind of implement this by embedding Lua and Lua Bridge into your code base. As far as getting the first few test suites of Homework 7 finished, this is the one, okay? This is the presentation you really are going to want to check out. But we didn't quite finish it all, okay? We got toward the end, but not quite to the end. So I have a challenge for you, and we'll see if you can notice anything wrong with the following code, okay? So what is the issue with the following code? How does the following code fail? Any idea? This is actually C# code, but the principles are the same in C++. How does the following code fail? This code wants to print a bunch of courses that we can take next semester. Interestingly, you know I made these slides quite a while ago because 298 is not on them. Neither is Game Engine Architecture on it. Okay? We're going to iterate through and we're going to remove EECS 498 from this list because we already took 498. You're in the course, right? But something is going to go wrong here. Very wrong, actually. And this is a big thing you have to think about a little bit on Homework 7.
Well, you're iterating through the array of modifiers. You're like for loop conditions based on the array that you're modifying.
Yeah. Typically, it isn't considered valid to iterate through a container and alter that container at the same time, alter its contents. So this can get you blown up. The issue is right here. If you try and run the C# code, you're going to get an invalid operation exception. Collection was modified. Enumeration operation is not allowed to execute, okay? Basically, we need to find a way to alter this collection without, not during iteration of the collection, okay? In other words, don't modify a container while iterating through it. You might think then, well, what about an index-based loop instead of a range-based loop? Because that's what this is. The for each loop will consider every item in your container, one after another. That's not the only way to iterate, okay? So here is a little fix-up, okay? Is this fine? What happens here? What does it print? Yes?
The indices will go out of sync because you removed course.
Exactly. When we print this code, something nasty is going to happen, okay? This is what's going to happen, all right? We're going to print not EECS498 because we remove it, right? But interestingly, right, we do print EECS440, SI311, PAT305, Education 333. You know what we didn't print? EECS494. Now, we didn't try to remove EECS494. In fact, we didn't move EECS494. We have a set, a container, we have a list of 5 elements in it after this code runs, but we only end up printing 4 of them. What happens? Well, what happens is this. Our index is 0, and we discover that EECS498 is at that 0th index. And so we remove EECS498. Boom, that goes away. Now everything has been shifted upward. Okay, it's been shifted to the left. And so EECS494 is now at the 0th index. But we do continue, which means we have now moved our index I to 1. We skipped over 494. Okay? So, how do we resolve something like this? Here's an ugly way to do it. Okay? We can fix up that little skip that we do by remembering to subtract from our index. The index gets pushed from 0 to -1, and then, because of this continue, the -1 becomes 0 again. Kind of a hacky, nasty solution. And if you are using an unsigned int, which is sometimes used in loops, then that's going to be a big problem, isn't it? All right, because you can't go negative. You may very well become a gigantic number when you're forced to go less than 0 in an unsigned int. Crazy. So, does anyone have any ideas for a cleaner fix? What could we do? Yes?
Well, first of all, we can remember the index that we want to remove.
Yep.
And we just print everything out, continue one cycle for the element that we want to remove, and then we remove it only after the for loop.
Yeah, absolutely. This is a pretty common pattern, and it's one you're going to want to use on homework 7. And I'll explain why in just a bit. This is a collect then alter pattern, and here's the idea. We are going to have our initial list of courses that we want to take, but we are also going to have a temporary list, a list of integers. These are the indices that we want to remove. And so when we iterate through this course list, we are not going to remove anything. We're just going to remember where that thing was that we wanted to remove. Then, after we are done iterating through the courses to take next semester list, then we can go through and we can actually fix things up, okay? We can iterate through our courses to remove list. And notice here that we're actually moving through this in reverse, okay? What happens if we were to go through our indices to remove and remove them in order, in normal order? The problem is that the indices will be invalidated when we remove the first one, okay? Everything will shift. Suddenly, we need to make sure to decrement the indices in order to fix that up, and that's really annoying. So you can kind of fix this by going backward through your index array. Now, when you remove things, it won't shift anything that matters, all right? And you'll be fine. All right, this is, basically you're marking stuff for removal, but you don't remove right away. And you iterate backward to not mess up the indices. I find this a little bit weird and surprising still. Here's something that I think is much more beautiful, but it's less performant. You are removing based on the content rather than the index, okay? So you're basically kind of just keeping track of what string you want to remove, and then you can go through it later and remove that thing. Now this, if there are dupes allowed in the list, then this gets a little bit hairier, and you have to be a little bit more careful, because you might need to remove multiple things from the list, but it is going to be a little bit less performant, but I think it's a bit more pleasing from a code perspective, okay? So why does this matter to your game engines? What is this little tangent about? Well, here's the thing, okay? When you enter Lua land, when the Lua starts executing, you have no guarantees about what the user might try and do in the Lua, okay? The user could do all sorts of things in the Lua, and you just have to make sure it works, no matter what they try and do. Here's something that you can try, okay? And here's probably how you're gonna do it. You're gonna have some sort of data structure for your actor. And this data structure is going to keep track of the key of your component and the component that corresponds with that key. You're gonna iterate through these components in the alphabetical order of their key. And you're going to need to check whether the game object, the actor, is active. If it's not active, you can't process anything. So you would just stop, okay? You will use that component, which in this case is component.second. Component.first is the key, right? So a string, basically the name of the component, if it can be said to have a name. So you're going to grab that Lua ref, the component, and then you're going to grab a reference to that onUpdate function, maybe the onStart function. You need to grab a reference to the .enabled properly because you need to check it. If a component isn't enabled, then you can't run its lifecycle functions. So then we're going to do something you might not have done for a while, or maybe even ever. We're going to use what's called a try block. Okay? Does anyone know what a try block is? Yeah.
It's, if you ever run into an error, it will go to the catch loop and do something.
Yes, it's exception handling. So if an error occurs within a try block, then what's going to happen is the program won't crash. It will return to this catch block, and then it will just execute the code within it and then carry on its day. Now, usually, you don't use try-catch blocks in your normal programming. Why? You want your code to crash if you have a bug, if you have an error. That is a big hint that you have a problem. And you can work backwards from the core dump even to figure out what line this happened on and then solve the bug, right? A perfectly written program doesn't need a try-catch block, right? Wrong. Okay? This is a very good example of something you've probably never done before. This try-catch block is what we call a sandbox, a quarantine. Okay? As part of the design of your program, you admit this fact. You don't have full control over how your game engine works or what it does. Why? You have another user involved in all of this. Who? The developer, the game designer. Your core user of your engine is going to write code that you do not control. Okay? This is kind of like the developers of Chrome at Google. They know how their Chrome engine works, but they have no idea what website you're going to visit. And they have no idea what JavaScript is going to be on that website that you visit. Okay? And so Chrome, web browsers, Firefox, in general, they also have a sandbox. And a big class of security issues arises when some rogue JavaScript is somehow able to escape the Chrome sandbox and try and take over your PC, okay? And so here's kind of what you're doing, all right? You don't know if the Lua that your game designer writes is going to be buggy as hell, okay? That could violate all the rules. That could be a terrible piece of code. And so you have to kind of sandbox that, and that's what you're doing with the try-catch, okay? The Lua code might totally fail and have all sorts of bugs and errors and exceptions, but your engine is not allowed to crash, okay? And that's what the try-catch allows us to do. We are not trying to recover from your errors. We're trying to recover from something the user might accidentally do, okay? So I think that's a really interesting distinction. Some people discover try and catch blocks. They write an error and they think, oh, this is a way for me to deal with my own bugs. No, okay? You solve your bugs. You write an excellent program, you fix all of your bugs, you crash. No, you're no longer crashing because you fixed all your bugs. But you can't fix bugs for code that you don't know what it's going to be, okay? So that is just kind of the philosophical situation here. Here's another thing to think about. In here, we are checking this Lua ref, this enabled Lua ref variable. We cast it to a bool, we check if it's true. If it's true, we can run our stuff. We call onUpdate, which is a Lua function that we did not write. And you know what this onUpdate function might do? It might create new actors. It could add new components to our current actor. It could destroy the component that we are literally currently on, okay? And that would be invalidating the data structure that we're iterating through while we're iterating through it. Okay, that is a big class of bug you'll have to solve on homework 7. It's not that hard to solve this, and you can use the techniques we showed in there. And I think in discussion they have some good ideas as well. But you just want to be very careful about this, okay? We are iterating through a bunch of components, and each component might decide, when we call its onUpdate function, to add more components to the same data structure, okay? My advice is to not add them to that data structure until the very end of the frame, at which point you actually have a guarantee that you are not iterating through those components anymore. Thus, you can alter the container then, all right? So consider that, because you've got functions on here that can create actors, destroy actors, add components, remove components, all sorts of crazy business. And that's, I think, part of what makes it fun. You are trying to enable as much power for your users as you can. And when you get all of this to work, right? When you get all of this to work, it's really, really elegant stuff. And I think you're going to feel very proud of your work once you finish homework 7. But you won't feel as proud of it if you finish it like a month late. Okay? So please try and do what you can to finish up homework 7, at least to get rolling this evening if you can. All right. What I want to do is I want to build a game with you. And I'm going to show you the game that we made last time. And maybe we'll build the full game. Maybe we can't build the full game. But notice when I download this game that we made in 2024, I download it, and the only thing it actually is a resources folder. That is it. Here it is. Okay. Now, how do we actually run this game? Does anyone know? Anyone know? Yes?
Just like copy paste it into your game engine.
Yeah, pretty much. It's just a normal resources folder. If I wanted to, I could create a brand new game. I'm going to call this my super cool game. If I want to send it to a friend, I could do this. And I'm going to take my resources folder and I'm just going to kind of paste it in just like that. Now I need an executable. Well, I can get that from Visual Studio, can't I? I'm going to go to, not my game engine, but I'm going to go to the homework 7 solution, which looks exactly like your repo. Oh, actually, I'm going to pull it first like this. I think I already built it recently, so I think we're fine. I'm going to go into the x64 folder, release folder, and then I'm going to find my executable right here, okay? And then I'm going to run this. I'm going to try and run this and watch this. Oh, it starts, but it blows up. What is this called, by the way? Is this a static linking issue? No, this is a dynamic linking issue, okay? The executable was successfully built, but the DLLs we need at runtime, the operating system is looking for them, it doesn't find them, okay? So we're missing these 4 DLLs, which means we do need to package them together. So let's find those DLLs if we can. Where are they? Where are they? Do you see them? Here they are, right at the bottom. There we go. So I'm just going to copy them right in. And then this is kind of the minimal amount of stuff we need. And I can play my game. All right, I'd forgotten how cool this was. We've got camera following. I can shoot these little bullets. I can run around. We see the different angles when I walk in a direction. Yeah, you know, this could have been made in Unity for 494's P1, right? Maybe. It's kind of a top-down Zelda-style game. All right, well, that's really cool. But you know what? I bet the Winter 2025 game is even cooler. So let's open this up. This is Crash Bandicoot 5. Any of you Crash Bandicoot fans? My first game ever was Crash Bandicoot, okay? And again, it's just a resources folder, so I can come in here, and you could actually download these if you want to and read the source code and get used to how things work. I can grab this, just bring it right over, and let's go ahead and play this game now. Okay? Got Crash Bandicoot, and I'm just kind of running around, and this boulder's chasing me. And we got boulders chasing me more and more as time goes on. They just keep spawning in. All right, so I'm getting overwhelmed by these boulders, and then boom, if I run into the boulder, we switch to another scene where Crash gets flattened. Bad ending, right? Okay, there we go. And it's even a full screen. That's kind of neat. So we can, if we want to, we can go in and we can make whatever game that we want. Theoretically, we could even make a 3D game if we really, really wanted to. But I want to make a new game of some sort. And so I am going to go in, I'm going to get rid of these images. I'm going to go in to this basic folder structure. I'm going to get rid of, I'm even going to get rid of all my components. Okay, I'm going to get rid of all of my actor templates. The boulder is going bye-bye. I'm going to get rid of all of my scenes. And I'm going to look in game.config. We will need a gameplay scene. Okay, actually, you know what? I take it back. I'm bringing that back. Okay, I'm bringing gameplay scene back just because I don't want to have to write all this stuff. The actors, let me see right there. Let's go ahead and get rid of this. Okay, like that. We have no actors. All right, we have an actors array, but no actors. And then the resolution. It looks like 1920 by 1080. Okay, cool. The clear color is going to be R and G, so it's like a yellow or something. Let's make it like a pure red. It's going to be our clear color to the background. And then there we go. You know what we can do now? We can play our game. There it goes. That's our game. All right, what kind of game would you like to make? We have 45 minutes. Okay? What kind of game you want to make? First, I always like to start with a theme. So I need a cool theme. Should we make a fan game? Who wants to make a fan game? What's a popular game series or a popular series on TV or movie or something? What are we making? What? Someone just say something? Okay, what do we got? Come on, someone say it. This is your chance to watch a professional game dev make your dream game. Yes?
And we create Doodle Jump.
Doodle Jump. Let's go, all right? We got Doodle Jump. Okay, we're going to need some Doodle Jump sprites. Okay, some Doodle Jump sprites. Let's see if we can find them. The Spriters resource coming in so clutch. Crazy. Okay, that's not what I want. I want, like, yeah, this is kind of cool. I'm not sure. What is all this weird, like, space up here? Why is it like this? Anyway, okay, I'm going to download this. I'm going to look at the image right here. Okay, that looks really good. I like that a lot, okay? So we've got our Doodle Jump character right here. I'm going to end the game. It wasn't that fun anyway. And the game's called My Game. So, you know, that's a problem I already have with all this. I'm going to throw this image into our images folder, and I'm going to call this character Doodle. And I'm going to change the name of my game to is there like a doodle jump 2 that exists? So this is really important, okay? So I'm going to doodle jump 2. Doodle jump 2 exists, so we got to look for doodle jump 3. Doodle jump number 3 does not exist, okay? They never made a doodle, wait, is that doodle jump 3? Extra unlimited? I think these are fake doodle jump 3s, okay? They do not have the right to make their own doodle jump 3, so we will. Okay, doodle jump 3. So we have doodle jump 3 here. We're going to start into this gameplay scene, and if I want to make a really fantastic scene, we're going to need an actor. And our first actor that would make a lot of sense is Doodle. Okay, so we're going to make ourselves this object right here. And this is a JSON array, so we can put as many objects in here as we want, actually. I can just keep putting more JSON objects in here, but each JSON object in this actors array represents an actor, and actors have to have a certain thing, don't they? What do they have to have? They have to have a name, okay? And so this actor's name is going to be Doodle. But each actor, in order for it to actually do interesting things, it has to have something else beyond just a name. What does it have to have? A components. Is it an array? No, it's not an array. Okay, it's an object. Okay? And the reason is so that we can have this key value set up. And so, here's how it's going to look, okay? Our Doodle character has this components object, which is going to have its own objects in there. And so let's give our first component a name. What should our first component be? How about arrow key control, okay? And this is going to be a component whose type is literally, arrow key control. Actually, you know what I'm going to do? I'm just going to call this component 1 because it's going to be our first component, okay? That's it. All right, that's it for Doodle. But we're going to have another actor down here that I am going to name. I'm going to call this actor, let's call this the camera control. Camera controller, or camera manager. How about that? This game object is also going to have a components array, or a object. Its first component is going to be called, let me see here, it's going to have a type of, let's call this just camera manager. Okay, and you know what we should do? We should run this to make sure it's going to work, okay? Because it's very easy to make a single typo and then you're left debugging forever. And that's not that fun, okay? Just not. Okay, so let's go to our desktop where we're making this game, my super cool game. I'm going to run this and something horrible is going to happen. It crashes. It crashes immediately. And you know what's kind of bad about the engine? It doesn't show you any long-form error message either. If you are doing this in the editor, it will show you an error message in Visual Studio, but it won't here. So what's the problem? Well, the problem is that we have these two actors. We have the Doodle actor and we have the camera manager actor. Doodle has a component of type arrow key control, and the camera manager actor has a component of type camera manager. But the engine has no idea what these things are, not the slightest bit, and so it crashes. Not good, all right? So we need to go in and we need to create a new component. Let's go into resources, let's go into component types. We don't have anything. So I'm going to create a text document, and I'm going to call this, let's call this arrow key control .lua, all right? And I'm going to go in here, and I'm going to create a table, okay? Arrow key control equals a new table that is going to have that onStart function. Okay, there's our onStart function. And we're going to just make it run a little bit of code. Just to make sure everything is working, we're going to go hello from arrow key control. Okay? And that's it. That's the whole component. That's it, just like that. I'm going to take this arrow key control component, duplicate it, and we're going to name this one. What was the other one? Camera manager? Okay. Camera Manager. Okay, I double click on it, and now I've got arrow key control. A big source of bugs is like your file name says something, okay? And then your actual table, you forgot to rename it. That really confuses my engine and causes my engine to crash. So you have to remember, Camera Manager, okay? In an ideal situation, the engine detects that the user has done this and like sends up a little error message, say, hey, like you accidentally put a different table into this file that says one thing, but the table says something else, okay? So this is gonna be hello from Camera Manager. Sweet, okay? And you know what I'm gonna do? I'm actually gonna go into rendering. I'm gonna make this a little bit smaller so that we can actually see the message as it comes up. Okay, let's go ahead and run our game and see if we run into an error. And we do, uh-oh. Okay, what's the error gonna be? Let's take a look at this really quick. We got resources, we have our scene here. Our scene used to be working. It is actors, we have a name, we have components. That's a block, good, the type. Oh, I see the issue, do you see the issue? This is why most game engines that are very serious will add an integrated editor, okay? So you don't make the mistake that I made. What did I miss?
The type doesn't make quotation marks.
Bingo, that's it. It's right here. Okay, you need to have this in quotation marks. Don't you dare leave an extra comma anywhere or JSON will explode, okay? It's crazy. It's hard to believe it was designed that way. Okay, anyway, let's try and run it again. Let's see if it works now. No guarantee. Hey, it runs, and guess what? Not only do we see our window, but we also see hello from arrow key control and hello from Camera Manager. This is really, really good news, okay? And so, what do we want to do? Well, if we want to have a character, right, our character here, we don't want to just move him around. We want to be able to see our character, right? And if you look at all game engines, they always have a component that stores your position, right? And this is where we say, you know what we really need is we need a transform component. Okay, transform, let's create one. Just like that, and I'll zoom in so you can see the code a bit better. We're gonna go transform. Now, what kind of data do we want to store inside of a transform? Transforms usually don't have a whole lot of logic in them, but they have a lot of data. So we can do this, x equals 0, y equals 0. If you really wanted to, we could put rotation in there as well. But for now, it's just an x and a y. That's it, all right? So there we go. We have our x and a y. Now we have to make sure that our player character has that component. So it already has one component, so add on a second component just like this, okay? We'll give it another component, which I just did, and then we'll say, hey, this is a transform component, by the way. All right, rock and roll, good. Our Camera Manager probably doesn't care about a transform. It probably doesn't need it. It's just gonna move the camera around as we need to. But there we go. Now, if we run the game, we still won't see anything, all right? Because you need one more kind of fundamental component, and that is the sprite renderer. If you're making a 2D game, you need a sprite render. These two components, transform and sprite render, are so common to game engines that usually they'll be built in. They will be highly optimized. The component will be written in C++. So I don't know if you've looked ahead, but homework 8, the hardest thing about homework 8 is that you have to write a C++ component that is built in. It's built into the engine. The player, the game designer, can just get it. They don't have to write any Lua. It's going to be the rigid body component, and it's going to be powered by Box2D. But what's difficult is that it puts pressure on your architectural design within your engine because you will now have to manage Lua components and C++ components, and they all have to work seamlessly together. Okay, that's the hard part. Let's create ourselves a sprite renderer here. Here's how I'm going to do it. Okay, sprite renderer. Okay, that's right, right? No, It's rendered. So I got to get rid of this. There we go. Okay, so the sprite renderer doesn't care about storing its own x and y. You know why? Because in the onStart function, it is going to grab a transform. Self.transform equals actor get component transform. Okay? This line of code right here, if you're not used to Lua yet, it's a bit confusing, okay? We are storing a variable inside of this sprite render component that is the transform component of our current actor, okay? I.e., let me add the sprite render on real quick, okay, because we don't actually have it yet. Type sprite renderer. This sprite render component is grabbing a reference to this transform component, and it's storing it inside of this self.transform variable. We could also actually just make this t. How about that? Self.t. That will save us a little bit of code. Now, every frame we need to be drawing the player character. So we need to do something every frame, which means we need to use that powerful onUpdate lifecycle function. Now, how do we render something to the screen? This is where documentation is really important. The A2 engine, I actually haven't finished the documentation for it. You know what the best documentation for the A2 engine is? Oops, wrong course. You know what it is? It's the homework spec. So here, homework 7. I was looking at homework 7 a ton as I was making the other games for the a2engine.org website. So let's go find the code that allows us to render something to the screen. Which test case is that? Does anyone remember? I think it is test suite. Here we go. It's the image API. It's the image table. So if we want to render something really basic in the scene, we can do image.draw. We provide the name of the image we want, and we provide an X and a Y. Okay, that's it. Now a question for you. What's the image we want to draw? The thing about components is that this component, sprite render, is very general purpose. It could draw any image we want. It could draw the image for the player. It could draw the image for the enemy game objects, or the spike game objects, or some UI even. And so we actually want to make this image we're going to draw kind of a parameter of the component itself. So I will actually set up a little variable over here. And then what I'm going to do is in here, I'm going to go image dot, draw. And then the parameters were in this order, the thing to draw, so self.image, our image variable up here. And then we need an X. That X position is stored in our transform component, so we're going to go self.t.x. This is the X value that is literally inside of our transform component that is also on our actor. So self.t.y. And there we go. The last thing we have to do is we have to actually tell this component on the doodle, which image do we want to draw? The engine knows we want to draw something, but it doesn't know what that image variable should be. So I'm going to go image, and I'm going to set a variable. And if I recall the image we want to render, if we go look into the images folder, boom, it's doodle. It's doodle.png. In our engine, we don't specify .png. Maybe that's a design mistake. I feel like it probably is a design mistake, but you know, that's how it's going to be. So let's go ahead and run our game and see what happens. Oh, it explodes immediately. You know what's really great about this? Now, because the game doesn't crash, we're getting an error. Okay, so in the sprite render, in the Lua component, at line 10, there's an attempt to index a nil value, field t. So it's saying that t is not a thing that exists, okay? So let's go into that component. Let's go into our sprite render. Let's go to 10, okay? And it's complaining in particular about this t variable, okay? Now, what could be happening here? Oh, I know what the problem is. Can you see the problem? Yes?
Did we initialize the coordinates, starting coordinates?
We did, yeah. So the starting coordinates within our transform will default to 0, 0. I see the problem. Do you see it?
Is it the comma?
Is it the what?
The comma?
The Kaaba?
Is this image metric you need a comma? At the top?
No, this is fine.
Okay.
Okay, so this image variable will become, when this component starts rocking and rolling, it will be doodle. Okay? The problem is right here with actor. I forgot. Is this a local variable within our table, or is it a global variable? This is a global variable because I forgot to use self dot. Okay? Isn't it a killer? This is why you really want code completion. You want a compiler to be checking this stuff and helping you out. So, because you can just lose a ton of time as you're building a real deal game. And look at that. We have our doodle jump, okay? Our little doodle kid. Now, I don't like this a whole lot because I can't understand where our doodle guy is in place. So I need a background. Let's do a crumpled page background, okay? Oh my goodness, does this look amazing or what? And I'm just gonna steal it. Okay, this is not a commercial game. This is for educational purposes. So I don't, I think maybe we're okay. Maybe we'll get the cease and desist letter. Oh, this is a P, which I cannot handle. So you know what we're gonna do? Probably gonna do this. Okay, there we go. Okay, and you know what? I want to make this really super big, actually. So I'm going to come into GIMP, and I'm going to make it even bigger. I'm going to make it twice its normal size. Okay, so let's go times 2. There we go. That's pretty big. That's pretty chunky. Okay, and then export. Let's go to the desktop. Hello? Hello? It's open source software. Okay, let's go to not crash, but my super cool game. Is that the one? Yeah. Let's go into resources. Let's go into images, and I'm going to paste this. I'm just going to call this bg.png. But why did it change? Okay, bg.png. Sweet. Okay. So what I want to do is I want to render this background. The background itself is going to be yet another actor in here. So we're just kind of like adding more and more actors all the time. And I'm going to just kind of copy this in here. We're going to name it background. And then, do I need to create a new component called background? No. And this is the magic of composition. Okay, we already have a component that can do this. We need 2 components. We need a transform component, which will default to 0, 0. That's a great place to render the background. And then we're going to need a second component, which is that sprite render component. Okay, and we need to tell it not to render the doodle. We're going to tell it to render something else. We're going to tell it to render that bg.png. And so let's see what happens. Okay, we might accidentally cover up the doodle, okay, which is a problem. Okay, we've got this background, but we're covering up our doodle. Now, I know a way that we can solve this, okay? We know that the engine is going to run through the actors in order, and then it's going to run all the components in order. So we want the player's sprite render to render after the background sprite render. So you know what I can do? I can just take this actor and I can just move it right back here. Okay, so now the background actor is going to be rendered first, and then we'll render the actual player character on top of it just like that. Okay, not too bad. If you look, you also, in the advanced version of image.draw, so thank you. In image.drawx, there's a sorting order variable that we can use in order to bounce, all right? And so we can do that if we want to. Okay, so let's go ahead and say, well, you know what? I really want to have my character bouncing now. I want to have my character kind of bouncing up and down. And so we should probably give our player character a little bit of physics, okay? So let's call this, let's create a component. I'm going to call this bounce, all right? And this component, yeah, it's just going to be named bounce, and that's pretty much it. Let's go in and make that component. Hello? It just doesn't want me to be, oh, okay, there we go. All right, let's go into resources, let's go into component types, and I want to make my bounce component. This bounce component is a copy of our sprite render, so we need to rename it. We do not care about images. We also don't care about on start. What we care about is our velocity, okay? We care about what kind of velocity we currently have. So let's call this velocity y. And velocity y is going to start, how about it starts in a jump, okay? It's going to be -2, okay? Now, every frame of our game, we have to do something with this velocity. We're going to go self.velocity. We're going to make it increase, okay, and eventually become positive. So a negative number will send us upward, right? Remember, as we go up, our y position gets negative. We can make it positive to add this sense of gravity. So every frame, we're going to go self.y, self.vel y equals self.vel y plus 0.01. How about that? And then velocity means nothing if you don't apply it, right? Velocity is the derivative of position. So in other words, position needs to be altered by velocity. So you know what we're going to need to do? We're going to need to actually have that transform component. So we do actually need on start, okay? We're going to get that component. And remember this comma. This is an easy comma to forget, but this function is a key value set just like everything else, just like these up here. So we do need that comma so we can have the next one. So we're going to go self.t equals self.actor, get component. We're going to grab that transform component just like we did in the sprite render. Now we can alter what is inside of our t. So self.t.y is going to be self.t.y plus self.vel y, okay? Now, let's watch what happens here, because we're going to notice that we got a problem immediately, okay? Watch this, okay? Look at that. Did you see it? What happened? Oh my goodness, okay? We have way too much velocity. It's going way too fast, okay? So I'm going to make this 0.1, and maybe I need to make this a little bit less, like -1. Let's just kind of see what happens here, okay? Play it again. Okay, that's a little bit better, but actually it's still way too much, okay? 0.1, how about that? And so let's take a look. Okay, ooh, we're jumping, that nice floaty jump, and we're going back down, and whee, right? Okay, we're moving now. Things feel a lot better for us. We didn't ever finish our arrow key movement, did we? No, we didn't, okay? So I'm gonna go in, and I'm gonna grab that transform component, and then we have to go in and we have to actually add some reasonable code here. Okay, we don't really care about the message anymore, so we'll do this this on update function. I'll make this a little bit larger so you can see it better. Now we need to check what the inputs are. Okay, is the player pressing the right or left arrow key? Well, we need to know that. So let's go look for the input API. Where is this sucker? Okay, here it is, okay. And it's gonna be input.getKey, okay? And then I think it's just lowercase everything right, and that's gonna check if we're pressing that right arrow key. So let's do it. If input.getKey, and then we have to say, well, which key do you care about? I care about the right key. Then, okay, and then end. And the same thing over here, except we want to check left instead. So if we are holding the right arrow key, we probably want to have a movement speed variable. So let's do speed, and I'm going to set that to like, I don't know, like 0. It has to be small, I think, right? So 0.1 maybe. And we're going to go self.t. If we're holding that right arrow key, it's going to be self.t.x equals self.t.x plus self.speed, okay? And if we're holding left, it's going to be almost the same, except it's going to be negative. So there we go. A reminder that plus equals and minus equals is not a thing in Lua. Okay, it's just not a thing, which is a shame because it would save us a bit of pain. All right. Well, there we go. Let's see if this is going to work for us. You really got to be testing all the time. See, look at that. Not too bad, is it? All right. We could add more features like having having Doodle character like look around as we walk around, as we change direction. But what I kind of want to do is let's see if we can find something that is like a nice little block. Okay, and let's say that this block is going to be something like 100 by 100. Yeah, something like that. And this block, I don't know. I don't really like this particular color. I like red a lot, but it's too harsh of a red. Okay, so I'm going to go ahead and just kind of draw myself something a little bit nicer. And maybe I'll come in here and I'm going to grab myself a nice cool blue. Something like that. It's not too bad. And I can just kind of grab it, make my brush really big, and just knock it out like that. I'm going to go to Select Invert, so I've got the border now. And now I'm going to come in here, and I'm going to go to the color wheel. Okay, can I get the color wheel here, please? Let's see here. I'm going to go like, I'm going to go a little bit darker. Maybe like that. I don't know. No, I don't like that. I don't like that at all. No, we got to go... where's the hue? There we go. I'm going to go down a little bit in the value, and we'll see if we can get something that pops. I like that a lot more, okay? This is pretty good. So we've made ourselves a block, which is great. Let's go into images. I'm going to just call this block, let me see, .png. Okay, there we go. We've got ourselves a block. I want to come in here and say, well, I want an object, right? I want an object. And so we're going to go to Gameplay Scene. Let's go and create let's create a block or two. I'm going to go in and we're going to create another object. Let's call this block. And I'm going to give it a components array. And let's say we want to have that first component be, again, a type of transform. And that's really good, okay? We'll start the block at, we're going to start the block someplace else, okay? We're going to keep the x at 0, but we're going to make the y down a little bit. So let's make it like 2. We also need this block to actually have some unique functionality so we can like land on it. So we probably want to give it a component called block or blocking, all right? Actually, I'll just make it blocking, okay? And we also want to be able to see this block, so we really want to have ourselves a sprite render as well. So I'm going to grab this. We don't want to have the duplicate key. That will confuse the engine a lot. So let's go ahead and add that in there. Just make sure I named it correctly. Resources, images, block. It needs to be a lowercase b, okay? Okay, now let's go ahead and run this and just see if we can see the block that we just created. You see how, like, you never move fast in this engine, but you're not moving super slow either. Okay, we got to go in. Oh, you know why? We don't have a blocking yet. Okay, we got to create that blocking component, capital B. So let's go in here, and I'll just grab the sprite render, I guess, and we'll name this blocking. Okay, we got our blocking component. And just name it like this real quick. I'll tell you, this isn't going to do a whole lot except to register itself in a larger data structure, which is something that you might not be used to doing in Lua. I have to kind of remember how to do it myself, but we'll see how that goes in just a second. I might have to look up some help here. Okay, so let's go ahead and run this and make sure it runs. Make sure we can see the block underneath us, ideally. There we go. There's a cool little block, right? Okay, so the idea is if we touch this block, then we want to detect that, and we want to bounce ourselves back up. We'll give ourselves that velocity again, okay? You know what I'm going to do, though, before we do that? I'm going to see if I can do this really fast. You know what I want to do? I like this block, and I know that I'm going to need more of this block. So what am I going to do? I'm going to need a lot of blocks, actually. So what can I do? Any ideas? I'm going to create an actor template because I know I'm going to need a lot of blocks. So I'm going to name this a block. Let's call this block.template. I think that's the extension, what it has to be. This is going to be a JSON object, so I'll open this thing up. Okay, I'm going to paste this character in, this actor right in, and this is now our template, okay? So we can now instantiate this. If you're from Unity, then we just made a prefab, okay? If you're from Unreal Engine, we just made a blueprint. So we now have our block, and we need something in our game to actually instantiate a bunch of blocks. And so we're going to create ourselves another simple game object. This one is going to be called the Game Manager. And the Game Manager is going to have its own Game Manager component. And this Game Manager component is going to be responsible for instantiating all of these blocks wherever we want them. So I create GameManager.lua. Let's go in Game Manager. Oh my goodness. Okay, and then in onStart, we are going to instantiate a bunch of this stuff. So let's say that I want to have a really nice function, okay? Let's call this create block. This is going to be a function. It's going to be a member function, and it is going to take an X position and a Y position. And when we get that X and that Y, we know we want to create a block. So let's create a new block variable, okay? It's going to be actor.instantiate. This is a function you have to implement that's capable of creating new actors. We have to tell it what actor do we want. Well, I want the block template. So this is going to make me a new block, but then I have to move that block to where it needs to be. So I'm going to go new block dot get component. Okay, why? Because in order to move a block, I have to get its transform component. That's where the X and Y for the block is stored. So I'm going to get that transform. I'm going to put this into a variable local new t. Okay, and then I can go new t dot x is equal to x position. I can go new t, okay, dot y equals y position. And now what I can do is I can call this function. And you know what's really crazy? Like, this actually doesn't need the self-reference. I could make this a global variable if I wanted to. I don't think I will, but I could. If I wanted to call this create block function from anywhere in the entire code base, I could do that, okay? But I'm going to just call it here, so I don't really care. I'm going to leave it as a member function, even though it doesn't use the local instance of Game Manager. Okay, so here's what I'm going to do. I'm going to call self create block. The double colon, the double dot here sends in the self-reference for me. So I'm going to call, I want 0. Actually, let's try 2. Just see if it's working. I'm going to expect it to be in the bottom right corner. Okay, so let's see what happens. And it explodes. Okay, what do we got here? All right, end local new block equals actor.instantiate. I'm fairly certain that exists. New t, new block. Okay, it's right there. Get component transform. We've got new t, x position. Oh, that's it right there. There we go. Okay, I accidentally put underscores there like I often do. Okay, and it explodes again. Okay, so self create block, that is a function. This is fine. We got end, we got starting, we got ending. Let's go over here to Game Manager. Can you see the issue? The comma got me. Can you believe it? Brutal, absolutely brutal.
Wait, you put an S.
Oh, did I? Did I get blown up again? Oh, you're right. I put an S in. Okay. There we go. There we go. We do have another error, though. Bad argument. Game Engine 11, argument number 1, actor expected got a string. Oh, you're right. Okay, we got a string. Let's go to Game Manager. It's 11. New block, get component. That is an actor, isn't it? Oh, yeah, I need to call this with the self-reference. Otherwise, it doesn't know what actor I want. Okay, there you go. Okay. There we go. So I now have a function that is creating these blocks for us. I don't have this block down here anymore, but I can very easily create a level by just combining a bunch of calls like this. So let's put this out there a little bit more, and I'm going to put 1 at -3, and I'm going to put 1 kind of down here. How about at, I don't know, like 0, 0, 2. Yeah, let's sync these ones a little bit more, just so it looks a little bit cooler. And I can just start creating content really quickly like this, right? And I could hook this up to something like tiled to make things even faster. Now, the challenge is, how do we do the collision detection? So here's an idea for you. We have all these blocks. All of these block templates that we're instantiating, all these block actors, they have this blocking component, which is right here. Now, what we could do here is we could do something like this. In my game manager, I'm going to create a global variable. Let's call this blocking. Let's just call this blocks, okay? And I'm going to create an empty table just like that. That's a global variable that I just created. And because Game Manager runs before setting everything up, we know this table is going to be ready. And so now what I want to do is I want to insert my transform into this block array. Okay, actually, let's call this, to be a bit more specific, blocking transforms. So in the blocking .lua component, in onStart, I need to get myself a transform. Okay, let's go local t. I'm going to go self.actor to get my transform component into that t variable. Let's go get component. Let's call this transform. And now I need to register within that global table. I need to put that t in there. And so what can I do? Well, in order to insert stuff, and this is something I don't do a lot, so I might mess this up, but you need to use table.insert. This is a global function, table.insert, that takes a table. In this case, is blocking transforms is the table we care about, and then the thing we want to insert into it, like this. And I'm going to verify that really quickly. So let's go table.insert Lua, just so I can verify this so I don't get blown up. Table.insert. Okay, the table and then the value you want to put in. I did get it right, okay? I did remember it. So now, what do we have? Well, we're going to have a table during gameplay that is going to be holding all of our transforms in it. So now what we can do is we can have this little section, process gravity up here. But now we need to go check for collisions. And so what can we do? Well, we can iterate through this set of transforms. And we can say, well, can I do this for t in, let's go blocking transforms, do end. Okay, and I actually want to print something just to make sure this is working properly and I got the syntax right. Found a transform. Okay, and now let's go ahead and, this should, we should get 3 of these, and I'm going to write one more thing so we can delimit this, okay, like that. Let's see what happens. We should probably see 3 found a transform every single frame, if this is working. Okay, and it explodes instead. What do we got? Okay, attempt to call a table value for iterator, oh yeah, okay, I forgot. You need to have a iPairs here. So you either need to provide pairs or iPairs, and that informs Lua as to how you want to iterate through a table, because a table is always a key value set of, it's a set of key values, right? So this is working perfectly. We can see that we found all 3 of these transforms. And now, what we can probably do is we can check whether we're colliding with it. You know what I'm going to do? I'm actually just going to get the delta. This is not AABB. But what I'm going to do here is I'm going to check for where we are. So let me see. The center, no, it's going to be the center. It's going to be the center of all objects. So let's do this. Let's do a local xd, so x delta, is going to be the absolute value, so math.absolute of, let me see, we need our player, don't we? Yeah, we totally need our player. We have that, it's self.t. We need the t, oh, we have it for the other object. Okay, so it's going to be self.t versus t. So self.t .x minus t.x. Okay, that is the delta for our character, and then the y is going to be yd. It's going to be math.absolute value of self.t.y minus t.y. So we say, well, you know, how big is our object? If the delta is on the x values larger than our half of our box, okay, then we've hit. So I think that's going to be like 0.5 units, I think. So let's go if xd is larger than 0.5, then we've got a hit, okay? Actually, no, if it's smaller than 0.5, we've got a hit. But we also have to make sure that the y is, I think, smaller than 0.5 as well, right? Okay. Then let's print debug.log hit, okay? And we'll just kind of see what happens. So let's run the game here. Okay, we got some issues. What's the issue here? Local T. Okay, so local T on line 17 doesn't like that. So let's go line 17. It doesn't like this T right here. Why doesn't it like this? Oh, it's because I messed this up. Okay, it's IT. I is the index, T is the actual transform that we are accessing. So let's get back into it. Okay, there we go. And it's not printing anything, not printing anything. Ready, ready? Boom. Not too bad, huh? And let's test it again. I'm going to try and go through the cracks now. Let's see if we shouldn't get any message. No message. And I'm going to go through the cracks on the left side, and if this goes through, total victory. Total victory, okay? You can book it. The whole thing is finished just about now, because you know what I'm going to do? I'm going to take our self.vel y value, and I'm going to set it to that initial negative value right here, okay? And so I'm going to run this, and we're literally at 6 o'clock, and here we go. And when we come down, we get that big hit. Okay, boom. Right? It's a little bit weird because we're kind of going into the object a little bit, but not too bad, is it? Not too bad. And so you could create a game manager that is progressively spawning in new things. It looks at where the player's position is, right, which you can find via actor.find. That's how you can grab any game object, any actor that exists via its name. And then you can check the transform component to figure out how high we're getting and spawn in new blocks using that fantastic create block function that we made. You can just go. And you could also have the game manager detect when you've fallen off the screen so you can restart the game. Okay? This is a real game. Okay? And I could have made this about twice as fast if I wasn't kind of explaining everything I was doing. But a note, it is difficult to make a game with this setup because just a tiny little typo blows you up. Okay? This tells you the importance of good error messages to help you locate where the problem is. But it also goes to show just how valuable it can be to have an integrated editor to try and cut down on those typos that you might be typing. Right? When you're making an engine for a customer base, you want to be watching them use your engine. You watch them use a tool. You make the tool, you watch them use the tool very closely, and you watch for where are people losing time? Where are people getting frustrated, and how can I save them time, help them reach their objectives faster? And if you do that consistently, people will love your tool. I know this because this is also how we improve our courses over time. We read your feedback, and we watch carefully to figure out where are you spending your time, and we decide, is that a good spend of time or a bad spend of time? And how do we make sure the students are trying to spend as much of their time on interesting problems instead of the boring problems that don't teach you anything, okay? Anyway, we've got our little game here, and I think it's not too bad for 45 minutes. So one of the best things you can do to understand Homework 7, but also to study for the final exam, is to make your own game. And I'm going to tell you, okay, don't get too sad, everyone, but we're introducing a final exam for this semester. But guess what? It's going to be a take-home exam. It's going to be a checkbox exam, whether or not you did it. And the only thing you're going to have to do is make a tiny little game with your engine, and you're going to get all the points. Okay? That's not too bad, is it? you're going to get a lot of points. It's going to help you out. If you've been losing points to those late penalties, you're going to be real happy. You're going to say, Austin, Professor Yarger, thank you so much for giving me a final exam this semester. Oh my gosh. Okay. Yes, question.
How would that affect the grade calculations?
So what's going to happen is in our first semester, we had a game jam that students did after for their final exam, like after the semester was finished. And that was very flexible. You could come and go when you wanted, and you got a bunch of points for that. I think it ended up being, in that semester, it ended up being about 10 points, but I'm probably going to make it a bit more valuable because I do want you to take a little bit of that time after the semester ends. After your exams are finished, we're going to give you time so that you can kind of focus on your other courses, and then you've got some extra time. So make a quick game with your engine. Boom, you get the points. Okay? That's probably how it's going to go. All right? So easy points. Yep.
How do we generate random numbers in Lua?
There's a random function in Lua. Yeah. I think it might be math.random, or maybe it's random.seed. That's how you seed it. But then you can do random.float, I think. There are some random number functions. Like you look it up once, and then you just use it, and it's no big deal. Okay? So any other questions? I'm going to put this entire game. You want to watch me distribute this game to my friends? Here it is. Ready? Oopsie, don't start back up. Okay, here we go. Are you ready? My super cool game. I'm going to call this Doodle Jump 3. And I'm going to, it's open yeah, I can't do that. So I'm going to quit this real quick. I'm going to rename this to Doodle Jump 3. I'm then going to zip it up, okay? And then, all right, I'm going to zip it up. Here's the zip file. I'm going to use ShareX to upload this super quickly. And then I'm going to come to the winter 2026 result, and I'm just going to put this right in here as a link. Cool. Now all of you can play the game at home if you want to, at least if you're on Windows. I'm working on so actually I think I finished the feature. So I announced it on Discord, but when you get a grade report from here on out, at the very end below your final score, there's going to be one final link. It's the build. We build your game engine, so now we're going to upload your game engine for you. We're going to store it for you and give you a link. So if you want to get quick and easy access to the Windows, Mac, and Linux version of your engine, you can just go to your grade report for that platform. It'll be right there at the bottom. We built it for you to do your testing and grading, so now we're uploading it for you and giving you the link to it as well. So what you would do for Macintosh or Linux is you'd have to put the correct executable in there. Or maybe you could actually zip it up. So do you see how Doodle Jump 3, do you see how this folder has the Windows executable and the Windows DLLs? I think you could hypothetically put the Mac app in there or the Mac executable in there and the Linux executable in there. And if someone zipped it or downloaded the zip and opened it up on Mac, they just see it right there. I don't think they can double click it to launch it. I think they can do that on Linux, depending on the the distro. But yeah, it was a pain in the butt. You know why? Because Mac is like always a pain in the butt. Getting stuff signed properly so that you can just download it and just run it. The big problem is on Mac, your friend would have to launch it from terminal, which they're not going to know how to do if they're not a developer. So I have to figure out how to not only build your Mac version of your engine, but then I have to figure out how to put it into a .app file as well, and then zip it up and let you download it. And I have no idea how to do that. I'm not a big Mac guy, but maybe I'll figure it out eventually. In any case, okay, know that that's a thing now, and you can distribute your own games that easily to friends. All right? Easiest if your friend uses a Windows machine. Okay, any questions or comments? All right. I think this stuff is just crazy fun. Like, I had a really good time making the 3 games on a2engine.org. It was even fun, like, integrating the tiled editor so I could make different levels and stuff. I hope that you start to have a lot of fun with your engine as well, because it's really going to make the rest of the course very pleasant for you, and you're gonna learn so much about your engine that the final exam is going to be literally cake. The best thing you can actually do to get really comfy with Lua is use it to make a game. Like, I kid you not, usually I struggle on this demonstration a lot more, and it takes like an hour or two. But because I recently made these games, it's like, yeah, I just remember everything. And I even remember how to debug everything because I made all those little issues 100 times making these sample games. Okay, so anyway, I'm going to be around for the next 2 hours. I'm probably going to step out to use the restroom real quick, and then I'll be back for 2 hours of office hours. I hope you find it pleasant to get back into the swing of things, right? A break is very nice, but it's kind of cool to get back into the grind too, okay? Hopefully it won't be too bad of a grind. Hopefully it will be satisfying. But all of you, I will see you on Wednesday, okay? Have a good one, and otherwise I'll see you for the next 2 hours. You can write your name up here if you want to start getting office hours queue going, and I will start going down the queue in about 5 minutes, okay? See you then. Okay, everyone online, thank you for joining us, and we'll see you next time. We'll see you next time. Bye-bye.